Hello, I'm Robert Evans. I'm the technical lead of the Windows App Consult team, and I'd like to share with you a modernization story. So this is a real-world customer scenario. They have a Windows Forms application and certain requirements, and they're looking to modernize. So let's walk through it. First of all, why, right? Um, they have thousands of users and high DPI monitors really show like grainy uh, bad rendering for their Windows Forms line of business application. Touch support is another big one. They have, lots of their users have tablets and touch-enabled monitors, and it's really difficult to get that working well with their Windows Forms app. Inking, they want to support that. Their embedded browser doesn't have support for HTML5. Part of the Windows Forms app has that. Version change, deployment nightmares, and one of the caveats here is that they still have to support Windows 7 customers in their enterprise space. So whatever solution we come up with has to have that fallback backwards compatibility. So here's the steps. First, we're going to recreate the current application, the Windows Forms application. Then we're going to migrate it to core and enable high DPI. Um, the, the application that we need to recreate has to support the dynamic creation of controls at runtime. So that's one of the requirements here. Um, and yeah, then we're going to, step 3, add Xaml Islands, dynamic controls. Then we'll add the MSIX packaging to top it all off. So starting off with recreating the current application. Like I said, it needs to dynamically add controls at runtime. And that's the way this is designed, their current application, and stress that it must be scrollable. So as they add more and more controls to their form, then it needs to scroll down and show all those controls. And needs to have support for saving as an XML and retrieving, their custom definition of the form. Now, we want to do a pretty simplified version. I understand what they have now is fairly complex, and ours is just going to show the basics. So let's get started. We'll go ahead and create the project, and we'll do a Windows Forms application. We'll do .NET Framework, call it Dynamic Windows Forms. So yeah, February 13th, my birthday, 2002, well, 18 years ago, was when Windows Forms was released. And it's this event-driven application supported by the .NET Framework. All the visual elements are class libraries that derive from the control class. It makes it easy to drag and drop and quickly prototype. I still use Windows Forms today for doing any really quick and dirty prototyping. If I need to do some testing in the regular .NET framework, makes it really easy and quick to just do some prototyping and testing. And yeah, it's in let's see, the Connect event in 2018 was when we announced that we were opening up Windows Forms as an open source project on GitHub. So yeah, today it's released under the MIT license, and it's become available for any of the projects now that are targeting .NET Core, which I'll show you a little later. So anyway, yeah, we'll go through here. We're creating menu items, for the opening and saving, since that's one of the requirements. Go open, and we need to be saving as well. And let's add a combo box so we can define which types of controls we want to add to the form. go. Speeding through this as fast as I can. Need a button to add that control to the form. Call it add. And we'll add a flow layout panel. This has been around for a while, since .NET 2.0, I believe. And it works really kind of similar to a wrap panel in UWP. It'll allow you to do like a stack panel, but it can go in either direction, horizontal or vertical. So we'll be using that we'll add the actual controls to that. There we go. We'll say cancel. Okay. Let's rename this something, form dynamic. And yeah, we need to open up files. We're going to save files and open files here. And what else? Yeah, we want to scroll this up and down. And we do want it to scroll. Okay. Now, let's start wiring things up. We need to add some helper classes. I've got some code that I've already written to speed this up. We'll create an enum to represent the types that we want to support, like text box and button and everything. Just copy these over. And need a couple of more helper classes. So knowing in advance that we're going to need different types of controls, the Xaml Island controls, UWP via Xaml Islands, as well as standard controls. We'll create a factory pattern here. So we'll say get the control, we'll pass in the control type enum, and then that guy is going to return the actual control that we want. So for now, we just need one type of that, which is the .NET framework type, and we'll derive that from control factory, implement that abstract. There we go. There's my override. So Windows Forms, is this open source graphical class library. It gives you a rich client application for desktop, laptop, tablet applications. It's seen as a replacement for the earlier, more complex C++, MFCs, the foundation class libraries. And, all right, so we're going to call out to my control helper and get text box. So I'll just fill these in a second here. Let's And we'll have one for each of these types. So obviously we want to get a checkbox. I can do control period and then generate method that I can then fill in. Radio control P period, auto generate that file. This is called coding by intention. Notes, generate that. Calendar and browser. Okay, so now we'll need to add some data helpers. We'll need a way, POCO plain old class library, a way to represent these controls. I'll just make it simplified. We need the name, or the type name, I should say. And really, for now, that's about it. You can make this far more complicated and add, an integer for width and height if you wanted. But for our purposes, we'll keep it simple. And then I need a container for that, basically, in order to serialize the entire collection, I need a container for it, because we are going to XML serialize it. The order does matter. We'll do a list, and we'll just call that controls. And we should give it a file name as well. Okay, so things are starting to take shape now. We need to XML serialize this. And I need to start wiring up the add button. Okay. My code by intention failed me here. First of all, this should be a string. I'll fix that in a second. So we'll leverage a new helper class, control helper, to help me determine what is the enum type here. I'll move that up to my control helpers. And once I have the type, obviously if there's no type identified, we'll just return. Make that nullable. Make this nullable. And yeah, I'll need to do a little bit of parsing, using some snippets to speed things up. Okay. System text, thank you. My IntelliSense is not working very well. Okay, so we have that. Let's wire up the event handlers for our save and for our open. we'll new that up. And some code that I wrote earlier, inserting that to speed things up a bit here. There's my save. And that looks pretty good. Now we need to open as well. Control period, auto-generate that. So when we're choosing file open, then we want to read the file, use the XML serializer, and then populate the page. And for populating the page, all we need to do is go through all the controls in my control collection and then add them. After clearing them out. Let's create our new control factory of type.net. And we want to, remember, scroll to that control once we've added it. So we'll scroll that into view. There we go. Beautiful. And the browser. Okay. So this is good. Now we've got a starting point, and it's regular .NET Framework 4.7.2, but it adds custom controls. You can see that. And oops, combo box. You can see that's working. Yep. Notes, we have calendar and browser. All right. And let's test out the saving of this. So we'll just call it my test. And there's my test. We can open this up. Take a look. Okay, so pretty straightforward XML serialized version of this, right? Now let's clear the controls and open that up. There's my test. Boom, there we go. Cool. All right, so this is our baseline, and this is our starting point. Okay, now let's move on to part 2. We're going to migrate this to core and enable high DPI. So .NET Core and in the future .NET 5, which is built on top of Core, will be the future of .NET. We're committed to support .NET Framework for years. However, it won't be receiving any new features. Only those that are added to .NET Core and eventually .NET 5, which is in preview. So to improve the Windows desktop stacks and enable .NET, we're putting all of our work into Core. And we have a simplified project, CS Proj in Core, as you can see. So I just went in, deleted all that. Say my target framework is Core 3.1. And now we'll reload that. And I'm going to need, yep, there we go. Can verify now it's targeting Core 3.1. It's nice, this new project format, you don't have to reference all the files that you're including in your project anymore. And there I've added the app config. And we're going to need a addition of DPI awareness. So application configuration, DPI awareness. And then let's see, we're going to also need a manifest. So we'll just go add that. And you can see here it's got several sections that are commented out by default. This lists the versions which have been tested, and for us, we want to support Windows 10 to start with. We'll go beyond that later. And set our max tested version. And here's the DPI awareness settings. So we can just uncomment that. And add one more node, DPI awareness. And we also want to enable themes, for common controls and dialogues. So we'll uncomment that. Dependency on Windows Common Controls. .NET Core, gives us side-by-side deployment, so you can have multiple .NET Core versions on the same machine. You can do self-contained deployments, so you can deploy, have it completely independent of your end user's environment. And since we're going to be adding the Xaml Islands, we're going to add a couple of NuGet packages as well. First of all, you can see I'm getting some errors here. Reflection, assembly, company attribute, all of that. This is all in the assemblyinfo.cs. Which is located under the properties here. And I don't need any of that now that I've converted over to Core, so we'll just go ahead and remove it all, delete it, rebuild. You can see I've succeeded. Go back to managing my NuGet packages, and we can start adding the toolkit packages, which I'll need for XAML forms. So we'll add the toolkit forms.ui to controls. Yeah, .NET Core also allows you to build smaller apps. So, in .NET Core 3, we introduced a feature called Linker, also sometimes called a trimmer, and that analyzes your code. And if you're doing self-contained deployments, only those assemblies from core that are needed will be included. So all the platform parts that you don't use will be trimmed out. You can do single exe files. You can package your app as a single exe and massively improve runtime performance. So core has a lot of performance optimizations compared to the .NET framework. A lot of the BCLs were completely refactored in core. All right, so we've got our web view, and now finally we just need our UI XAML host. So the toolkit forms UI controls, like the ink canvas, are individual controls that have been wrapped, and they're all open source. You can go and look at the source for these if you want. The XAML host will allow us to host the UWP controls, like standard controls like text box and button and slider, etc. Okay, so now that we've got those added, we can start to add what we're going to need for the UWP controls. All right, so now we've got our button. All right, so we've enabled high-DPI. Starting with .NET Framework 4.7, Windows Forms includes enhancements for common high DPI and dynamic DPI scenarios, like support for dynamic DPI, like where the user changes the DPI or the scale factor after the Forms application has been launched. So now we've enabled that support. And now we're going to add the actual XAML Islands and dynamic controls. We've also converted our project to core. So let's expand our factory. So we've got our factory for net. We've got a factory pattern. We're going to need a new one for our XAML Island controls. XAML Islands is this technology that allows Windows developers to use new pieces of UI from the UWP, Universal Windows Platform, into your existing Win32 applications, whether it's Windows Forms or WPF. And that allows you to gradually modernize your application at your own pace, making use of the current code however you want, like this scenario that we're doing today. So we're going to create a new helper class, XAML Island controls. And for this, we'll use the toolkit XAML host, Windows XAML host. So it's like the other .NET control factory that we have, except we're going to return the equivalent control using our XAML host. All right, fast forward this a little bit. I've already written this, so like I did before, just cut and paste. We're going to have media player. We'll have the new web view control. And it's using the windows.ui.xaml namespace. And we have an ink canvas. And we need to expand our control enum to add those values. So yeah, back in 2012 with Windows 8, we introduced a new framework to modernize Win32 APIs that was called Windows Runtime that had a lot of new controls. These controls are part of the visual framework called XAML, which is part of the Windows Runtime. And back then, if you wanted to use any of these cool controls, you'd have to create a brand new UWP app. In the middle of 2015, we introduced Windows 10. UWP was born. And then in 2015, we also announced Project Centennial, which is later called Desktop Bridge. It's this set of tools that allow developers to bring your existing apps to the store. There's a new packaging system. So you could convert, your MSI to an AppX and then later bring it to the store. This gave you an application identity, which allowed you to leverage some of the UWP controls. And later on, we added more and more capabilities to it, like live tiles and notifications. But still, there was no UI controls. It was the advent of Xaml Islands that brings these UI controls to your existing Win32 applications. All right, so now we've got our factory in place. We've got our helper that's going to generate our XAML Island controls. Now we need to call it. And all right. And here's our factory pattern. You can see right now it's just using the .NET. Come back and fix that in a minute. And here, this is important to point out. So what I'm doing here is checking if it's an append action. So we want to minimize the number of Windows XAML hosts that we have on our form for performance reasons. So what I'm doing is checking if the prior control that was added is also a XAML Island, UWP control. If so, then instead of adding a new one, I'm just going to append it to the last one. Missing that method. Go. So again, missing the namespace. So here I'm going to get the actual UWP control. Let's just replace all of these. So here we want to actually do the factory pattern, right? So instead of just defaulting to the .NET version, we want to check, is it XAML? If so, give me the no, not the new style UI parser. It's IntelliSense being aggressive. There we go. Or give me the .NET standard one. Not .NET standard, .NET. You know what I'm saying? There we go. All right, so now we have an actual factory pattern going on. Get the control type, get the control, add it to the flow panel, and scroll to it. There we go. Oops. So you can see these are much nicer than the built-in Windows Forms controls. You can theme them. They've got you know, they work out of the box with touch. Much nicer. And ink and ink canvas. Map. I don't have like the Bing key set up for this, but you get the idea. And the web view control, which is, a huge improvement over the standard web view in WinForms, which uses IE instead of the Chromium engine. There we go, side by side. And we support save. There we go. Now, remember part of our requirements is for this to run on .NET, for this to run on Windows 7 SP1. So let's go ahead and add a Boolean to determine if we're running on a supported OS, like Windows 10 1903, or on an earlier version or not. So to do so, I'm just going to check the OS version. There are, on the UWP side, is API contract present, runtime checks like that. They will not work in this scenario because we're not going to be on Windows 10. We're going to be on Windows 7 SP1. So now that we have that, we can just check, is Xaml Islands supported or not? And I'm just going to override it and say is XAML's false if we're not. So if we're running on Windows 7, it'll fall back to the equivalent Windows Forms control. And then we want to go in here and uncomment this. Say we support Windows 7. Build succeeded. We'll go in here to Terminal. To have it open over here. And we'll just do a .NET publish. Not quite sure what the warning there is for. So I did earlier run into a publish problem, and I had to add that target, which I understand is like a workaround to a .NET Core publish bug that they're still working on. Anyhow, we've successfully published. Let me open up the right directory here. Hold on. There we go. There's my publish. And I've got a remote desktop to Windows 7 SP1 over here. I'm just going to paste my published .NET Core project and run it. There we go. So you can see the .NET Framework dynamic adding of controls still works. And if I go try to add UWP, it's just defaulting to the equivalent .NET Framework version if it exists. See that? Awesome. All right, so we've got XAML Islands working and we've got everything working on Windows 10. Now let's add MSIX packaging. MSIX is a Windows app package format that gives you the modern packaging experience for all Windows apps. It preserves the functionality of your existing apps, allows you to install things in addition to enabling new modern package deployment features for your Win32, WPF, and Windows Forms applications. So we're going to leverage this WAP project, Windows App Packaging Project, and we're going to set it as our startup, and we're going to point this by adding a reference to our existing project. This is going to take the output from our .NET Core and package it up into an MSIX. You can just create these manually, add apex package. There's a variety of third-party tools as well that you can leverage to create your app packages. And we'll go ahead and generate some images here. MSIX gives you a reliable install experience, and it reduces network bandwidth. By leveraging the differential updates feature, so only updates in the 64K block are downloaded. That saves network bandwidth. And all right, so we're generating some images from my son's surf picture here. These are going to end up being our assets, our different tiles. There we go, generated those. So you can see how they have different scale factors depending on the resolution of the monitor and which tile size the end user is selected. So there we go, packaging that up. And let's go ahead and debug. So what's really cool here is when we debug, it's going to package our application as an MSIX, install it locally, and then debug right into it. Here we go. So this is running within the container. And we can stop that. Now if we do deploy, that'll actually install the application. So if you wanted to test it outside of debug, see how it behaves, there we go. It's added it right there. And we can go to publish. You see enable automatic updates. If I do that option, then it'll give me a UNC or a file share, or you can publish also out your app installer to a website, and then it'll pull updates when you update the version. So we're going to sign it and go ahead and create our package. There we go. It's adding all the resources to the package. All the output from our .NET Core application. It's doing a make Apex. You know, that tool that comes with the SDK, make Apex, you can actually leverage that directly to do packaging from the command line if you want. It's sometimes useful if you find that you're missing something in your package. There we go. It's all done. So let's open that up. And here is our package. And here is the certificate for the package. So we first need to go ahead and install that cert. We need to install it to trusted people. Now, obviously, in a production environment, you wouldn't need to do this, or if you're installing from the store, you don't need to do this. But for debugging development purposes, you need to. So what's really cool about MSIX packaged applications is the protection of your system. So if, for example, an MSIX package application tries to write to the registry, those writes are redirected to a local registry hive. Then when it does a read, it reads the actual registry and combines it with its local registry hive. So from the application's perspective, it thinks it's reading and writing to the real registry, but your system's being protected. So that's great for most applications. For applications that depend on that, leveraging the registry for communication, then it becomes a problem. And there we go. Similarly, system files and system folders, like your OS, are protected from writes. So you'll get a crash if that happens, if you're packaged in as MSIX. All right, so now we have it all packaged up. Let's go ahead and make it work on Windows 7. So to do that, we're going to have to leverage MSIX Core. which is open source. MSIX Core brings MSIX support to versions of Windows earlier than Windows 10. Now, 10.1709 is when MSIX was first supported. Core is this open source project. It's out on GitHub. So we're going to add this target device family and 6.7.1. That's referring to Windows 7 SP1, by the way. We'll go ahead and package it. In this case, we don't want a bundle. Bundle is, if you're targeting multiple architectures. We're just going to do x64 and MSIX. And now we're going to copy the cert and the package over to my VM I have over here running in Azure. So with MSIX Core, yeah, you can run it on Windows 7 SP1, Windows 8.1, and Windows 10 versions prior to 1709. It'll work and install, which I'll show you in a minute. But keep in mind, you don't get the protection benefits that you do on Windows 10 1709. So for example, any of the registry rights are just going to be regular registry rights, and the system files and folders are not protected either. There isn't what some people call container protections on the lower systems. So you might say, well, why would I do that then? Well, it gives you one package format that you can distribute anywhere, so almost anywhere, to most of your user base. Instead of having to have an MSI as well as an MSIX, you can just have one package. And there we go. It's up and running now on Windows 7, behaving the same way. Beautiful. Well, that's it. We've taken a Windows 7 application, added Windows 10 features to it, migrated to .NET Core for performance improvements. We've implemented high-DPI, DPI awareness, and finally MSIX packaging. And the source code for this, I'm going to do a blog and upload it to aka MS App Consult blog. So go look there and you'll see the GitHub source and all that. Hope you enjoyed it. Thanks.